one of the things you're going to be asked to do is to find an equation through 2 points. So the first thing in order to find your equation is you're going to need to find the slope, or that's one of the things you're going to have to do, is find the slope of the line. And then after that, you can substitute the slope and one of the points into y equals mx plus b to find the y-intercept, and then you can write the equation. The other thing you could do, just thinking about this, we did on a previous lesson, you guys were given information and you had to write an equation with those. And so we looked at how the y's changed, how the x's changed. We did the y divided by x, which was our slope. And then we said, just take that and adjust it. So you could otherwise use the slope and adjust your equation to make it work like we did previously. And that wasn't really how I was taught. I was taught of substituting it in. You've got to do it this way and then work it and find the y-intercept. But we could probably get by with that otherwise, just looking at how we can adjust the equation to make it work with the points we have. So if we look at problem 4, it says what equation in slope-intercept form represents the line that passes through the points 2, 1, and 5, negative 8. So the first thing is they found the slope. So like what we've done before, slope is change in y over change in x. And we just need to make sure we remember what our x's and our y's are. It's real easy to get these in the wrong spots and then we'll miss the problem. So they did negative 8 minus 1 over 5 minus 2. You could have otherwise, if you started with 1 for the y value, you could have done 1 minus negative 8. If I start with the 1 for the y, I have to start with the 2 for the x. So that would be another option of doing this, is putting them in the other order. That would be 9 over negative 3. 9 divided by negative 3 is negative 3. And that's the same as the answer they had. So the slope is negative 3. So what does that mean? Well, that means that in this y equals mx plus b, we know one of our missing pieces. We know m is equal to negative 3. So it's y equals negative 3x plus something. We don't know what the something is. So the one option you have, like the book's doing, is they're substituting a point in. So they just pick, and it doesn't matter which one you picked. They put the point 2, 1 back in that equation along with the slope of negative 3. They just substituted and they worked it out. Now they didn't show all their steps here because otherwise they show every single step on every single problem. You'd probably have a heavy book to carry around, or heavier, I guess I should say. But that's how you finish that off. So then the y-intercept is 7, and then you put that back in here. The other option, like I mentioned, is you guys could just try to adjust it. So like your point was 2, 1. So if you put a 2 in for x, we're wanting to get 1. Well, negative 3 times 2 is negative 6. So how do we get from negative 6 to 1? From negative 6 to 1, we would have to add 7. So add 7. You can figure it out that way also. Okay, again, the book, you'll probably not find a book that's going to advise that method of like doing this adjustment, but it works all the same. So it really doesn't matter to me which way you do that. So if you look at the guide at 4, what equation in slope-intercept form represents the line that passes through the points 3, negative 2, and 1, negative 3? Another thing on these, if you guys want to, if you find it helpful, you could actually graph the points. Use graph paper, graph the points. You can find your slope that way. if the points are nice to work with. Just understand sometimes you might get, points like 800, 300, and really big numbers where it's maybe not going to be real convenient to like count squares on a graph. So it's good to also know how to work it out by hand if you need to. One thing nice about if you did graph these out, if you put them on graph paper, you could at least look at the graph and tell if it's supposed to be a positive or negative slope. So that would be one advantage, even though you don't have to. That's one advantage maybe of actually graphing them, even if you don't use the graph to figure out what your slope is. For the change in y, we could do -2 minus -3. These are both negative y values. Like I said, kind of like we're doing here, if you start with the biggest one first, -2 is bigger than -3, that'll allow you to have a positive number to work with. No guarantees on the x's then, but at least we're not going to end up with having to deal with a negative divided by a negative. So now we're locked in, and we have to do the same order for the x as we did for the y's. So since we started with -2 for the y's, for the x's we'll have to start with the 3. So we could do 3 minus 1. In the numerator, if you want to add the opposite there, you can. So in the numerator, -2 plus 3 is 1. In the denominator, 3 minus 1 is 2. So our slope is 1/2. So we've got one piece of the puzzle figured out here. Again, if you want to just write down your equation, is probably a good idea. Write that down to start with, and then we can kind of fill in pieces of the puzzle here. So the slope goes in place of the m is 1/2. So what we can do then is we need to figure out what our y-intercept is. Y-intercept, in order to get that, right now I know the slope, but besides the y-intercept, there's 2 other variables I don't know. I've got 3 variables right now that I don't know. So that's kind of a problem. That's not going to allow us to figure out the other one. What we're going to have to do then is take one of these points. It doesn't matter which one. So I'm just going to go with this one. So I'm going to go with the 3, -2. And I'm going to substitute those in place of the x and the y in my equation. Because if my slope's 1/2 and it goes through this point, I can substitute all that in. That'll leave me with just the y-intercept, just the b variable, and then I'll be able to figure out what it's equal to. So x is 3 and y is -2. Okay, once we've got that all substituted in, then it's just a matter of working this out, solving for the b. So you can put 3/1 here. So if you multiply, that would be 3/2. Just to make it a little easier for us to look at, I'm just going to say that's 1.5. Because then if I subtract 1.5, that's going to be easier for me to see what's happening over here. So -2 minus 1.5. I'm going to write it this way just so you guys can see what's going on. We could add the opposite there, and that would be -3.5 or -3.5. Okay, we could do decimals, just decimals aren't always going to work. So, and then a lot of times what they'll even do on this is they'll put that back as an improper fraction. So that would be -7/2. Okay, if you leave it as -3.5, that's okay. So now we know our slope and we know our y-intercept. So kind of just taking these pieces together, then our equation we could say is y equals 1/2 x minus 7/2, or you could say 1/2 x plus -7/2 if you wanted. Again, if you have -3.5 or -3.5, that works. What you'll find as you do these problems, though, is it's probably going to be easier for you just to leave it as a fraction, -7/2 or -7/2. And I'm not going to go through the whole thing here on this video, but if you put in a 1, -3, you could try that. Put in 1, -3 into the equation, and you'll get the same y-intercept. And like I mentioned also, we could use graph paper. We could graph this out, and we could try to see what our y-intercept is if the numbers aren't very big. So this one, the numbers aren't too bad. I could just graph these points if I wanted to, technically. So we've got 3, -2, and we've got 1, -3. And then if we draw a nice line here, then we can maybe tell where that's hitting the y-axis at. The problem is, anytime if it's in between like this, you know, I don't know exactly. I mean, it kind of looks like it's about -3.5, but is it -3.5 or -3 3/4, or, you know, in between? That's really not a definite thing there. Plus, if your graph isn't very straight, you know, it might even look like -4. So I wouldn't advise just going by the graph to try to find what your y-intercept is, although you could use that as a guide point of saying, okay, it's between, or it's around, you know, -3 to -4 range. So we just looked at how to find an equation if they give us information. The other thing is, we are going to sometimes have to graph equations. So to graph linear equations, what we can do is start at the y-intercept, and then we can use the slope to find another point on the line, starting from the y-intercept. So starting from the y-intercept, use the slope. For example, if the slope is 2/3, change in y is 2, change in x is 3, we could go up 2 and over 3 from that y-intercept to find another point, and then connect the points and put arrows on the ends, and then that could be our graph. We do have another option if you'd rather. If you don't like that method of doing it, another option is to make a table of points. Table of points, what you're doing is you're putting different x values in and then seeing what y values you get. Usually, well, first of all, I'd recommend using 3 x values, because, you know, if I have any two points, whether they're right or not, is going to make a line. If I can get 3 points to line up, that's a better indication that I've probably got a good equation there. So 3 x values, then substitute into your equation, see what you get for y. 0, 1, and 2 is usually what I would recommend, but if you have a fraction, then you're going to want to do multiples of the denominator. So just as a quick example, you know, if we had y equals 1/3 x plus 2, if I was doing a table, I would do a 0, and then my denominator is 3, so I could do a 0, 3, and then the next multiple of 3 is 6. So 0, 3, and 6 could be my x values. The reason I'm picking those as my x values is because that's going to give me numbers, y values that are not fractions. If you don't use multiples of that denominator, if you have a fraction, then you'll end up getting fractions for your y value, and then it makes it harder for you to graph. So problem 5, that's what they're doing, is what we just talked about. They went the graph of y equals 2x minus 1. So the first thing, like we talked about, they start with the y-intercept. Remember our equations like y equals mx plus b. So since this is minus something, if you want to add the opposite there, you can. So our y-intercept is -1. What does that mean? It means the graph goes through the point 0, -1. So that's what they started with. They started with the 0, -1, and then the slope is 2. So slope, remember, it's change in y over change in x. So if I have 2, it's not a fraction. I want it to be a fraction, so I can use that and go on my graph and see what this is going to do. So we know 2 we can put as 2 over 1. So change in y is 2, change in x is 1. Change in y is 2 means from that y-intercept we can go up 2. Change in x is 1 means we can go over 1, and we can put a dot there. That's where the blue dot is. And then at that point you can draw a line that goes through those 2 points. Okay? This way, if it makes sense to you, it's maybe a little bit quicker than the other method. The only downfall about this way is if you mess up, you're probably not going to know it. So the other option would have been, we could have made an XY chart here. There's no fractions, so we could have done 0, 1, and 2. And then we could substitute in. If you put a 0 in for x, you get -1. If you put a 1 in for x, I would recommend working this out to the side. I'm just going kind of a quick mode here, but if you put a 1 in for x, that'll be 2 minus 1, which is 1. If you put a 2 in for x, 2 times 2 is 4, minus 1 is 3. So the advantage of that is I've got 3 points. So 0, -1, 1, 1, those are the 2 that they've already got graphed there. And then the third point would be 2, 3, which you can see is right here. So that gives me 3 points, and then that's maybe a little bit more assurance that we actually have a good line instead of, I did start it at this point and I used my slope, there's my other point, and now I'm going to move on to the next problem. Okay? If you're comfortable doing it that other way, that's fine, but if you want a little bit more assurance that your graph's correct, you may want to do an X and Y chart. So if we look at the got it number 5, part A, if we go to graph this, we can start with our y-intercept. So y-intercept is 4, so we can start at the point 0, 4 if you're doing it that way. So if you want to use the first method we talked about, the slope is -3, which is -3 over 1. That's change in y over change in x. So -3 means from that point we would go down 3 units. Change in x is 1 means we go 1 to the right. And we can put a dot there. That's going to put us at the point 1, 1. Like I said, just be careful if you use that method, it's fine. But we just have to make sure that we've got the right points, because we don't have a safety net, so to speak. The other option is we could do a table. There's no fractions, so if you want to do 0, 1, and 2, if you put a 0 in, you'll get 4. If you put a 1 in, -3 plus 4 is 1. And if you put a 2 in, -6 plus 4 is -2. So 2, -2, you can see there, my graph, I was off just a little bit. And so that's another good thing, is it gives me a third point to line up and make sure that my graph's going the exact way that it should be. So part B, same idea. We're trying to find this graph here. So this one they're subtracting, so if you want to add the opposite there, you can. So this one, the y-intercept would be -8. That's just off the chart here on what I've got. Slope is 4, which is like 4 over 1. So if you wanted to, you could go from that point, you could go up 4 and over 1. And that would take us to this point, 1, -4. And again, we could draw a line through those points. This one, No guarantees since I went off the graph a little bit there. But graph should be something kind of like this. And the other option, like I said, is to do a chart. So if you put a 0 in, you'd get -8. Put a 1 in, you would get -4. Put a 2 in, 4 times 2 is 8. 8 plus -8, or 8 minus 8 is 0. So 2, 0. So we're not too far off there. And that would be our line. So the next part, slope-intercept form, is useful for modeling real-life situations where you're given a starting value. So starting value, or an initial value, is the y-intercept, and then a rate of change is the slope. So a lot of real-life applications we can use with this. So on problem 6, water pressure can be measured in atmospheres. Use the information in the diagram to write an equation that models the pressure Y at a depth of X meters. And what graph models the pressure? So you can see the information here. They're telling us at 0 meters the pressure is 1 atmosphere. So 0 meters, 1 atmosphere. That's my y-intercept. They're telling me right there my y-intercept is 1. And then the pressure increases by 1/10 of an atmosphere per meter. That's my slope. Okay, so from just that information, I can get right to here. Okay, that's the equation. And then they want us to graph that. So they graphed 0, 1, and then the slope is 1/10. This one a little bit different if you wanted to. I mean, we could go up. What you might want to do is just put that as a fraction instead of going up 1/10 and over 1. Just if you write it as a fraction 1/10, we could go up 1 and over 10. So up 1 and over 10, and that would take us to the point 10, 2. And again, your other option is just to substitute numbers in. This one, you might say, oh, it's not a fraction, it's a decimal. Well, it's a decimal, we can change it to a fraction to decide what to use. So if I was doing a chart, the chart method, I would do 0, 10, next multiple of 10 is 20. Those would be my x values I would pick, and then I could figure out what the y values are. So if you look at the guide at number 6, a plumber charges $65 fee for repair plus $35 per hour. Write an equation to model the total cost Y of a repair that takes X hours. And what graph models the total cost? So on this problem, our rate of change, if you see the something per something, that's your rate of change or slope. So 35 is our slope. And then the y-intercept is 65. And this might seem odd because it's like, oh, if we put in a 0 for X, we get 65. So like 0 hours and it's $65. Well, it's kind of a fee that like it takes them time to drive places and stuff like that. So maybe they get charged for that. Charge you for that. Also, excuse me. Also, if you had somebody show up and then you were like, oh, never mind, we got the problem fixed. You know, they might still have to charge you because they still used up their time and where they could have been doing something else. And then from there, the graph, I mean, you can do whatever you want. If we did a chart here, it would be 0, 65, 1, 100, and then 2 would be what, 70 plus 65, 135. Okay, and then we could graph those. Make sure when you graph that you label, just like they did on problem 6 in your book, label the X as hours and label the Y as the total cost in dollars. So if we look at the lesson check number 4, the question is Y equals 5X, a linear equation, and explain. So what we've been talking about in this section is these equations, Y equals mx plus b. So if you look at that equation, it's kind of missing a part there, isn't it? The question is, can I do something to make it look like that? So what we can do to get it there, we can put it as Y equals 0x plus 5. 0x, 0 times anything is just 0. So we're allowed to do that. And that actually then is still a linear equation then. It's just our slope is 0 and our y-intercept is 5. Slope is 0 is going to be a horizontal line whenever we graph that out. One thing we can't have, that's x equals something, or y equals something. If we had x equals something, that's going to be a vertical line. And then that's, I guess it's linear. That's not a function though. So to kind of make sure you look at what question it is that they're asking you. So this gives you an idea of how to work with slope-intercept form.